There we go. I think it's working. I'm going to be using this stream to test a few things out with the music. So not having it just pick up off the mic. No, is it? Come on, Twitch. Oh, there we go. Okay, it's working. Is it? So, yeah, we shall see how this goes. This like, prepare for a disaster, because I've basically not set up at all. Also, because of the lighting is just like, yeah. So, well, on the desk it actually looks fine. It's just, like, I can't really point the camera up because the windows are right behind me, and that's just gonna blow out. There we go. Yeah, we're live. Yay. So, is it really dark, or is that just me and the... Okay, so... music? So, that's... How is that for people? Just tell me on the chat how that is, because, I have no idea. I'm experimenting with it, and we can turn it up or down or whatever. It's just a case of, yeah. Really damn loud. Okay. Will be sort of... I'm really not sure how, like, it's... The freaking volume levels don't tell me anything, so... Just, like, the meters might as well be arbitrary. It's just, yeah, there's noise. I don't know how much. Is that better? So, yeah, today we're gonna try Burn My House Down 2.0. We're gonna build the... okay, the phone's chat is just terrible. I'm gonna have to keep this... There has to be some way to set this to not turn off the screen, is there? I have no idea. Safety, application, battery, power saving, battery. Let's see. I have no idea. Okay, so I'm probably not gonna be able to... Well, I'm not gonna be... So I'll still have to try to, like, see the chat from, like, halfway across the room. Great, perfect, absolutely lovely. Useless pile of garbage. So, the plan for today is to make this spit out a voltage. That's pretty much all I want to do. And this right here is what's left of the RX 480 GTR. I pulled off the... Okay, pulled off is the wrong term. I have ripped off, very forcefully, the DVI connector. I've chopped all of this here, all of this of the board off with just a saw. Do I have that saw near me? Nope, it's on the other side of the room. Used this to remove it. This right here. And I'm not sponsored by Wilco. Just so happens they tend to have a lot of random junk that I need. So, yeah, I use this to cut this off of the rest of the card. So what we have here is the IR3567B, the VRM that's left of it, and yeah, that's the back of the board. Now, I've sort of already connected the 12-volt power planes with that blob of solder right there. Except that looks awful, and I don't really trust it to work properly. So... So basically, the plan is I'm going to be hooking up the 12 volts on the back here as well. And yeah, and we'll also get this to fire up. So this is what I have for actually getting the thing to turn on, so... And this is just a SATA extension. Let me just open that up. There we go. So, we'll be cutting off... which end? Which end goes into the power supply? Damn it. So, yeah, we'll be cutting off this end. And the reason why I use this is because it's a really convenient source of 12 volts, which is the yellow line. It has a ground that's black, obviously. Red is 5 volts, white is 3.3, brown I have no idea, and quite frankly, don't care. So we're just going to not use that one at all. So at this point, we're going to get that attached to here, and I just realized, oh, well, I can use the phone for that as well. I need my data sheets, so we're going to go look those up right now. So I need a... Like, I've already gone over, like, the general plan of what I'm doing on the... in the video on the YouTube channel about the RX 480 GTR power board plan. So, PCIe, pinout, that should just take me to Wikipedia. Perfect. So, basically I've left on the 1X part of the PCIe connector. Well, actually no, this isn't even 1X, this is just power. This is just PCIe power right here. This is 3.3 volts and 12 volts. So we'll hook those up. And this is the easiest way to get 3.3 and 12 volts everywhere on the card. Though the 12 volts is currently only, it's not actually going to get 12 volts to the VRM. So the VRM is going to go on its own little 6-pin connector. And I will be putting that onto the 6-pin through a choke, just for, because normally you have that on VRMs and there's no chokes left on this because they're typically right on the input of the power. So on the GTR, normally you had a choke here, choke in that area because, where's the, there, because this right here is a choke, this right here connects to the PCIe slot, that right there is the output to this side of the VRM, but I've sort of fused the two VRMs. This VRM gets its power from all the way on the, well, you know, somewhere over here, which isn't any longer there, so can't rely on that. But first we'll just want to hook up 12 volts and 3.3 through the PCIe slot, because that's the easy part. It won't turn on after we attach those. Okay, so actually I can show you on the phone now that I think about it. Yeah, so, and I can't zoom out enough. Let's see. Yeah, no, that's worse. Okay, so there's a PCIe pinout, sort of. So we have pin, damn it. Okay, I'm just gonna give up on that. It just doesn't work. So pin one on this side, I believe. This is always a thing for me, is just figuring out which side is which on Wikipedia. Okay, and the component side is B side. Right, yeah, that would make sense. Yeah, okay, so we can actually check that really easily, because I know this is this would be 12 volts for the VRM, so we can just stab that. If I get the multimeter on the screen. And of course, you won't be able to read it. No, this freaking thing. See, for me, it isn't a problem. I can read it just fine. It's just cameras and LCDs. No, don't fall over. There. So we'll basically just probe from that pin right there, which is the one on the very, you know, towards the connectors, and get that, and to here, and that should be, that is 0, so that's 12. The one next to that is 12. Yeah, which is exactly what I expected. And according to Wikipedia, well, I mean, according to Wikipedia, that's exactly what I was looking for. There's 2 more pins. Well, there's 3 pins on this side, and there's 2 more on the back. I'm going to find that third one. I'm only going to go for the 3 on the front here, because, quite frankly, I'm not going to be relying on the PCIe slot for most of the power. Most of the power is gonna come through this here, so I don't need to hook up a ton. I just need 12 volts for anything that might be running off of the PCIe slot, which, if I'm not mistaken, on this card, that would be the entire, like, all the driver ICs, they're hooked up straight to PCIe 12. So let's check the last one. Yeah, that's also 0. And then this pin right here, also 0. This one? Okay, this one is reading... Oh, I have it on volts. I'm an idiot. There we go. I am really... Yeah. This is just not gonna work, because I freaking... Okay, well, either way, I'm just gonna figure out which ones I need to solder onto, and then we're gonna go from there. Yeah, so the first one's 0. Second one's 0. Third one's 0. Fourth one is garbage. Perfect. It's like 7.7. Fourth one is supposed to be ground, and it's like 7.7 K ohms. So we can ignore that one. So at this point, I'm going to actually rip that extra pin out just to make sure that I don't accidentally short my 12 volts to ground, because that would really, really suck. And then we're going to solder on. So 1, 2, 3, you're going. Ta-da! So that guy's gonna be... There we go. Just wobble it off there. So that's that pin missing. And now we can hook up 12 volts to these 3. So, yeah. And then 3.3 volts is like... 3.3 volts is the harder one, because if I remember correctly, on the other RX 480 I've done, I did it from the back. So, I think it's... Well, it's over on the end. I think this capacitor right here is for 3.3 volts. We shall see. I need to check Wikipedia again. I really... Yeah, phones are not a thing for me. This is a mess. Okay, useless pile of garbage. Let me scroll. 3.3 just before last, according to this. Yeah, yeah, that's what it looks like. So, gonna do those. This time I'm actually gonna rely on Wikipedia, because I actually have no idea where the 3.3 volt plane on this card is. So I don't have a reference point to check against like I had for the 12 volts. There we go. But since I already figured out that I got the siding proper, then it's much easier to read the actual spec on Wikipedia. So now I know that this is side B, that's side A. So it's that was really the biggest concern, because after that it's easy. There. Perfect, that's relatively clean. There's 2 of these pins, so this next one right here should be TMS, and I have no idea what TMS is, nor do I really care. I just know I don't want to short 3.3 volts straight to it. So we're going to pull that one off. There we go. So, yeah. That pin is now missing. At this point, yeah, I could cut off all the rest of them, but that's honestly quite excessive. So now we'll need to get... Now we'll need to prepare this. How much length do I want on this? Thinking... So the thing I didn't like about my other power board, the other RX 480 I did, was that it was really bulky. The connectors and everything, it was... Like, I had them hanging off to the side, and it was awful. So this time I would like to put everything right behind the display outputs. which should be doable. I'm not sure if I should focus on putting everything on this side of the board, or if I should focus on putting everything on this side of the board. Like, if I should have all my connections, because I will have to run a wire on this side anyway. But I will be doing 12 volts. Kind of prefer this just having, because I do need to pull 3.3 from there. This is the easiest place to do 3.3, because on the front, your 3.3 volts are next, like, there's a pin in between them, which is just dumb trying to solder in there. Much more complicated. Generally, I do my hookup off of the back here anyway. I think I'm just gonna do the... I think I'm gonna do what I did always on the first one, which is where I had the 12 volts line sort of routed through the... This is what I did for the reference card, where I had the 12 volts line routed through sort of that way. It went like that. And then on the... And then the other two lines will just go straight to the back. And I'm going to power this thing, the drive voltage, I'm going to drive with 5 volts on this one. If I want to drive with 12 volts, then I can do that as well, but I want to do, like, the other one gets really, really hot just sitting the way it is, so I'm hoping that I can get this thing to run a little bit, like, a little bit more efficient, unloaded. And then if I ever want to add, you know, I can always just put a switch for 12 volts. I just currently don't have a switch that well, I do have some switches that could do it, but I'm not sure if they're high enough current, so, yeah. So, let's get this cut. And where did the wire cutters go? There they went. I think I'm gonna, yeah. It's gonna go down. On the RX 480 reference card, I actually had the 12 volt line go to sort of there. How did I think about it? If I just combined this monstrosity, like, that there. And then... nah. I'm gonna do it the... Because that's the thing, if I have all my 12 volt inputs going into the same thing, then they need to be on a... I need to put a choke. Which I'd like to avoid. Because of the VRM, and the reason why you put a choke after... for like the main power line for a VRM is basically because a VRM, as it switches on and off, creates a bunch of noise, and the choke behind that is there to suppress it. So yeah, I'll just cut this extra long to start with. So we'll just cut it off at the other end. Go. Pull the sleeve off. Now we got our wires. And where should I pull ground from? I mean, there's a convenient ground. Nah, that's not convenient at all. Let's see. I'm thinking something like that for the wire routing. And then that would go down to there. What does it say about the backside? I mean, technically, it wouldn't be that difficult to hook up both 3.3 volts and 12 volts on the back. And then I wouldn't have any of the whole, every stuff being on both sides issue. I've already prepared this side, though. Or, what I could also do is just join the... You know what? I think... the less garbage I have sitting on this side, the better, I think. So, I'm just gonna do everything on the back. So, I'm gonna combine those two first. And I should have a bit of spare wire somewhere here on this desk. Can't find it. Great. Well, we'll try to get... So, we'll try to combine these two, and I just want to check that I can actually even warm them up. That is the... 12-volt power planes, and that's almost as bad as trying to solder V-core or ground. Okay, so that side is easy. Yeah, that melts. This side, yeah, okay, that works. So let's figure out what I'll join it with, and then I'll hook up everything. There we go. That's one of the strands from a 8 gauge. Well, one of the sort of copper strandy bits from a 40 gauge wire, so I'm just going to use that to do it. Because that'll certainly handle the current, and should be relatively easy to get in place. Just going to try it. Let's see. That's too big. There we go. Yeah, that looks good to me. So I don't want to be holding that, because that is copper, so it's basically going to cook my hand if I try to, well, cook my fingers. Come here, damn it. Not above the board. Go. That's pretty much solid chunk of tin at this point. And into the board. Yeah. I should have pulled out the 150 watt for this. That would have been easier. That actually joined. I'm surprised. Oh, and now it's not. Damn it. Now it's not. Yeah, now it's not melting. The reason why all the e-power guides you'll ever read recommend really massive wattage irons. The reason for that is if you try to solder into anything sort of like a power plane, you're basically, the smaller irons just have no chance of actually melting anything. Because already this edge of the graphics card is warm, and I'm barely even managing to melt the solder right there. So what's the? See, how does that look? Kinda. Not a great connection though. If I had the 150, I could just press down on that and it would slowly sink into it while the entire board turned into untouchably hot piece of metal. But the 150 watt, that's the problem with that iron, is it's way too massive and hard to work with in general, so prefer not using it if I can afford to. But it looks like this would have really been a better job for that. And I don't think that's actually attached at all. Let's see. Yeah, that's coming right off. Should have done it from the other side first. So instead of trying to solder onto the VRM side, I'm going to solder onto attach it to the PCIe slot connection side, because that side, at least I know for sure, that one is easier to get through. Yeah, that one melts faster, so damn it. Oh. Good thing about this thing is it cools relatively fast, so the thingy, so I can actually hold it already. Unlike the PCB of this is getting warm noticeably, so. attach? I have no idea. Yeah, that looks terrible. Kind of starting to... Nah, actually, no. I'm not starting to regret removing that choke that originally was there, because that thing sucked. You know what? I'm going to shorten this instead of trying to force it down, which would work if I had a bigger iron, but then I could actually fit in there accurately. I'm going to shorten it a tad, and if I do that, I can actually... Well, the iron will get under... Well, next to it, and then it'll be easier to actually attach. I hate 12-volt power planes. I hate ground as well. Those are literally the two worst planes, but the nice thing is when you're not working on a... Damn it! Well, that flew apart. Where did the other end go? Okay, we're making another one of those, because that literally just... Oh well. Yeah, should have expected that. That blew apart, so... This time, smaller, because I did make it way too big when I was connecting it last time. Yeah. See, that actually gets me better access for the soldering iron, so that should work better. Instead of before, where it was so massive I couldn't actually get in there. Okay, well, let's make this one ready for action and try again. I'll probably find the one that flew apart when I tried to shorten it when I'm cleaning later or something, so do this. This thing's not wetting as easily as that other one. I have no idea why. Go. There, I'm gonna call that ready for installation. Let's try get it in there again. Come on, damn it. Get in. Wish I could just use my hands to hold everything. Nope, that's hollow. Fireproof hands would be great. I mean, heat-proof, something like that. Yeah, that's just not.
I feel everything. I can feel the rotation of the earth.
Okay, that's not working.
The blood in my veins. The vibrations.
Go. That's... Oh, why does this have to keep falling over? I need a third hand. One to hold the board, one to... No, four. One to hold the stupid little thing that I keep trying to add. Yeah, that's the angle I wanted at. Now stay like that. This is a pile of garbage. I don't know why I blow at this. It's just like an automatic reflex when Working on anything low on it makes it better. I have no idea why. Okay. There, that's attached. Shittily, but attached. That wasn't so hard, was it? Now we can do the other side. Which is going even worse because that side has a lot more mass to it. Because technically that one's connected to the V-core plane and the ground plane through the MOSFETs, so... And the capacitors have quite a lot of... All the 12-volt capacitors on this thing are also on that same... on that side, so... Right now I'm trying to solder onto the side with the most thermal capacity, and it's just going really great. Really great. There we go. The ugly pile of garbage now looks even uglier, but at least it is connected. Cut off the excess, and I don't think I have a heatsink that'll fit on this now. Ouch, that's hot. Shouldn't have tried to grab that. Yeah. Now those two 12-volt planes should be connected well enough that it won't. There. So now if I hook up 12 volts pretty much anywhere on the card, it's going to power everything. Which does mean I need to put a filter on the 12-volt line, but I'm not going to do that today because, well, actually I might. It doesn't really matter. I don't know how long I want to do this for. Go. The other side. Yeah, that looks like a pretty solid connection to me. Even if it's ugly as hell, at least it's connected. So now we actually have a connection from the PCIe slot all the way to, well, the entire VRM. The whole board's hot. Not unbearably yet, but it is warmer than me, so... Yeah. Go. Junk that ripped off. So, now we can actually hook up everything from the back or front or wherever. I don't really care. I'm going to hook up 3.3 volts first because that's technically, it's kind of the most important voltage. And then I'm going to pull 12 volts straight to one of the 12 volt capacitors because that's just convenient at this point. And I'm going to put the connector right like there. Is it a bit dark or is it... Should check the chat. Damn it, Twitch, open. I have no idea what I'm doing. There. Found it. Come on. So yeah, that's great. So we need to hook up 12 volts, 3.3. Just gonna prepare 3.3 already. So the nice thing about gold fingers is they wet super easy. There. Those are ready. Bam, done. Couldn't be easier. What, with the 710? The 710, like, I haven't done anything to the 710. The 730 died. And I pulled the RX 480 board off. So, there. And I actually want this to overhang a little bit, just to... Ooh! Damn it, phone. Non-physical buttons are the dumbest thing anybody's ever invented. You accidentally brush against your phone and it decides that, oh yeah, it's a great idea to get out of the chat. So now I lost the entire chat log. Love you. Great app. Great app. Absolutely lovely. They could also make something to make sure it stays on. That'd be awesome. But yeah, the cool thing is, I have these... So these were from the 2 of these DVI mounting points. These are really convenient because if I run any wires under the, like, between them, I can zip tie them down. Which is awesome. So I'll just clean this up to make the hole a bit bigger. I said clean it up, not make it worse. Let's try it from this side. If anybody's wondering if this is how you're supposed, like, is this good soldering that you're watching? No, this is the worst. Damn it, get through. I literally just, I missed the 150. The 150 went through this like so easily. It had just got near and it started melting. It didn't even need to really make contact. Because I used the 150 to remove the DVI connector, but working with that is like, it's already really hot because it's summer. And this room is west facing, so it just makes my day really great. Love the summer. Best time of the year ever. There, now we have a hole. That is actually usable. There. Kinda bored my way through it, so. Yeah, and so if I actually put this connector behind that, and yeah, so I can put this connector right there, and then we can zip tie it in place, and then we can put the PCIe power connector sort of... Oh, damn it. How big is this? This is going to need a ground. I'm going to ground it off of the capacitors for the 12 volts. That's probably the best idea. And then... it'll just about work, I think. I mean, I guess I could also zip tie across there, because I'm not going to really use that hole for anything. But... it would have been... I think it would have been nicer if I could get them all in one place, but... Let's see. Yeah, okay, screw it. So, I need this much. Give myself a bit extra. There. And strip that. And let's tin it. Perfect. That went nice and easy. So I should also figure out how much 12 volt I want at this point, and also 5 volt. And actually, speaking of the 5 volt, so I want to hook up to the drivers on this. And if you're wondering if you want to look at the data sheet on this for this card, you want to look at the CHL 8510 data sheet. It's available on Google. You can just Google it. You'll find it. So the thing about the 8510 is it has the lowest pin is something called LVCC, which is the low voltage, low side gate driver. And I want that one. And I want to basically LVCC and HVCC, which is the high side FET and the low side FET power supply for the gate. I want to hook those up to 5 volts. And the way I'm going to do that is I'm going to... Right, yeah, so basically the way I figured out where to get that hookup is the hookup's going to be right here. It's going to be these 2 points. For some reason, which I don't understand, this VRM actually has the gate drive for the top 3 FETs and the bottom 3 FETs separated. No idea why, but it is. So you can actually just bridge this right here. That connects the 2 gate drives. And this is also, since this bridges the gate drive, you can actually also hook up gate drive right there, which is super convenient. And unfortunately, I don't know if I'm going to be able to show you on the multimeter how that is hooked up because, well, I'm not an octopus as much as I wish I was. So I'm not going to be able to show you how, like, that hooks up. Because I've barely managed to figure out that with the in my own convenience. So I'm just actually just going to make absolutely sure I didn't screw up the first time, which is going to be really nightmarishly difficult, because one hand to hold this upright, one hand to, you know, probe, and just like, I need, it'd be so nice if I could just set this into space and it stayed immovable. That'd be amazing. Then I could probe it all I want, but nobody makes anything like that, because, like, I need some kind of gentle, non-PCB breaking vice thing to hold the damn thing in midair, which is just awesome. If I had a schematic, then this would be obviously just a case of look at the schematic and figure out where what goes, but the schematics for GPUs are not public for obvious reasons. But if we go, yeah, it's 0. Yeah, that's 0. So we'll just combine the two, which is just a case of this is close enough that I can basically just do a little bridge of solder like that. Oh. I need more solder for that. Because right now it's staying on the tip here. There. So now I have gate drive autofocus. Yeah, I need to stop jittering. Autofocus, could we? Right. Can we autofocus? Come on. There. So that right there is the combined. It doesn't show up. As far as I can tell, it doesn't show up. But, well, you'll see it once I hook up the SATA connector, which fell down, I guess, or something. Where did it go? There we go. So I want 5 volts to gate drive, and I'm actually going to leave an excessively long wire because I did say I want to experiment with hooking that up to a switch one day, so I'm just going to take the 5 volts as long as it is and hook that up right there as soon as we do the 3.3 volts first. So let's do that. Just going to be a case of, oh, the 3.3 is now hooked up. That was nice and easy. There. And at this point, I think I'm going to zip tie the connector into place just to make sure that it stops trying to run away every time well, just, it's loose. So, there we go. And let's go. Go. Oh, whoa, the zip tie is actually long enough to go all the way around, but I'm not going to run it all the way around just because if I take a second zip tie, I can probably get it there. Get it better connected if I just pull this one down on top of it, like so. There. And that connector is, well, yeah, it's not going to be perfect, but at least it's going to stay in that general position. Those. Ta-da! My connector doesn't run away anymore. 12 volts is really nearby, which is actually kind of inconvenient. I think, no, that's not a 12 volt plane. Trying to figure out a good hookup that isn't one of the capacitor legs, because generally those are a pain to solder onto, because the capacitors have a lot of thermal mass themselves, so heating up the leg of the capacitor to the point where it actually wets properly is actually kind of difficult on a GPU PCB. Just single capacitors on their own are easy, but once you put them on a card, it's a nightmare, so. Yeah, that looks acceptable, I'd say. Yeah. Okay. So we'll hook 12 volts straight to that, which is basically that. That's an awkward angle. That's really awkward. Because there's a ground point right next to that. There's really no better place I could 12. Okay, well, I'll start probing around again. Try to find a better place to put 12 volts on. Because I don't really want to do it where right off of one of these capacitors, because it's just, there's a ground point right next to it. See, if this was 12 volts, that'd be super awesome. Let's see. Because this is a huge pad. But I don't think it's 12. I think it's ground. Indeed, it is not 12. It is showing 900. Oh, about 1.5, 6. It just keeps, the resistance on it just keeps climbing, so that's great. What's this? That's in the mega ohms. I wonder if that's ground. Nope, that's still in the mega ohms. What's this? Yeah, that's ground. That right there is ground. So actually, I could pull the black line to that really easily. That'd be convenient. So we'll pull the black line to that. Ta-da! I should have probably prepped all my wires before. Order of operations is really whatever you find. If I had proper wire strippers, then this wouldn't be a problem. All I have is a box cutter! Ugh. There we go. That is terribly stripped. There's like half the one side is basically off, so if I get that. Oh, that'll work. Tin it, hook it up to ground. At this point, that's just... There we go. And now it just has to go like that. Ouch, that's hot. And this is the point where I start to smell PVC because it's a really nice ground plane. Got there. Okay. So for some reason that wire decided to get stuck in the upright position, so now I need to bend it back. Place. There we go. And there we go. Ground hooked up. And unhooked, well, not unhooked, but running away. I really don't like that. That looks like it's almost touching that capacitor next to it, which would suck. But let's see if I can get this to stay in place. Yeah, still moving. I'm gonna go get some blue tack. What do I have to do to make this thing not run away? There. Yeah, okay, that'll be better. Yeah. I can't use the blue tack directly on the PCB because the whole PCB gets hot as I work on it and it's going to start melting on me, so I need to put it a bit away. Don't touch the yellow wire. No, damn it. Wasn't that hard 3 seconds ago. I'm going to have to get my thumb in that. That looks really... Probably not shorted, but I don't like the way it looks. Yeah, I give up. I had that third... Move, damn it! Freaking hell. Yeah. I swear I'm gonna die of like poisoning by freaking PVC before anything else. This wire is gonna be so destroyed. Like the insulation is just completely wrecked at this point. It's still not one. Just let go. I want to pull you off. Yeah. Perfect. Oh, that's disgusting. If I had it, I should have made it slightly shorter than what I needed instead of slightly just running apart. These multi-stranded wires. This thing is really obnoxious. It's basically run itself into a massive, monstrous blob of just conductive crap, and anything I put near it's just way bigger than I need. There's a little bit of there. It just doesn't want to. And I'm at 400 degrees, so it's not like I'm too cold. It's just this thing sucks up way too much heat. Not melting, and it's falling apart again. Should have twisted this together before I started going for it, but I think that's a bit too late as a consideration. Yeah, the insulation on that is just busted. I think I might go for another SATA connector. Another one of these. Or I need to find a different ground, which is closer to the edge. This is so annoying. Like, on one side I have solder that just doesn't want to melt, and on the other end I have the insulation which melts way before the solder does, so it just never works out. Yeah, that's just completely busted. It's beyond saving at this point. What should I go for? Well, I could just find another ground. I mean, yeah, but that's like in the middle of the wires over there. Because there is a ground point right between them, which is for one of the connectors for the display output. I think that's one of the DisplayPort DVI outputs. That should be ground. Of course it's ground, right? Yeah, that's ground. But if I try to solder there, then I'm going to melt all the other wires as well, so that's not really an option. You know, I wonder why I've never thought about just having the SATA connector miles and miles away. That might be a better option instead of trying to make it all compact. Just have it hanging off a mile away from the rest of the card. It would certainly give me more wire to play with. Because this right here is just... this is just... I'm just going to pull off the whole thing at this point. At least SATA extensions aren't expensive. And now that's not melting either. There. That's completely disconnected again. 1 step forward, 3 steps back. Another extension. I did have 2 of these before I started, so I wonder where the second one went. There we go. Power boards, power boards, power boards. I'm just not even going to bother with trying to cable manage it at this point. I'm just going to go for it. And go for it with as long connections as just possible, because honestly, because then I can just zip tie it to whatever anyway, so it might work out better instead of trying to make it compact from the get-go. This pile of garbage. Then again, I don't need the brown wire, so I'm just going to pull that one off early for convenience. I don't even know what that wire does. So, there we go. Fresh, new 20 SATA power connector, and we're going to go 3.3. 5 volts right there. 12 volts wherever at this point, because I can attach it, and ground wherever. I think I'll still try to go for that ground, just because that's a nice place, but... Like, it's a nice big connection, and it's near to the VRM, but... Yeah. At this point, it really doesn't matter. Most of this is planning where you're going to attach things, not attaching them. Not much to attach, it's just figuring out how the board is wired, for the most part. So... Get that ground one ready. Oh. I'm not going to attach any of these until I have them all prepared, because it's easier to have a free connector when stripping wires and all that. So, yeah. There we go. This one. I think I went overboard on the side of this one, but doesn't matter. And that insulation just melts instantly. Get the 5 volt. Oh, I managed to do that one fast enough that that one actually looks good. And let's do the yellow one. There, that one's also not that bad. So, now let's hook these up. I think I'm gonna go for ground. No, ground's the... Right. No, I'm gonna start with the one that has to reach the furthest, which is the white one, and for some reason the white one, yeah, the insulation started melting on this one, and it's a bit oversized, so I'm gonna trim it down a bit. There we go. Up the white one like that. There, that's good. It's attached at this point, and it's falling in the wrong direction, but that's fine. 5 volts straight to there. There's too much uninsulated on that. But we can get ground easily enough. This will move a bit. There, that's a lot better. Now I can get 5 volts to the drivers, which I'll trim this down, because this is also, again, too long. And there we go, that's attached as well. And now we need 12 volts, which I can literally hook up to any of the capacitors at this point, which is great. So that actually was a good idea compared to the old one. Too bad that the wires are spaced like this. It's like, this one's a mile away from all the other, like, they're all a mile apart, so... This thing is just awful, but... This won't fire up right now, at least it shouldn't, but we will test if it fires, just because I hooked up all the voltages it has to have. If it doesn't fire up, then I still need to enable the voltage controller using pulling the enable pin high, which, you know, that's just pulling a 10k ohm resistor to 3.3 volts and then to that pin, after we figure out where to actually attach that. Though I might reference that from the other RX480 I've done, though I'm not 100% sure. Actually, no, I can't, because I plasti-dipped that VRM completely, so I can't use it for referencing, because all the finer connections are plasti-dipped to make sure that I don't break them by accident. Yeah, capacitor legs just never ever wet, do they? Ceramic caps are easy, but for some reason the electrolytics, well, the polymers, I should say, type of polymers are types of electrolytics, so doesn't super matter what I like. Yeah, it's you know, it's technically correct. But yeah. That off. And please attach. Can we pick up the card with that? Nope. Definitely nope. There's like one strand in that entire thing that's actually attached. So, if I get it like this. I'm gonna pick it up now. Nope. That's what I expected. Yeah, it just doesn't well on those. I have no idea. Because if I go there, it's like the connection's not even warm, and I've just had a 400-degree piece of metal sitting on that. So try scratch up the surface of that, because sometimes it's just the oxide layer on the tin solder that everything uses these days that you can't get through. So maybe that'll help. But I have my doubts. I might just have to find a better place to attach 12 volts. Like the gold fingers. Those are super easy to solder too. On the RX 480 reference card, I have the convenience of there being like, they have like there's a place on the PCB where they basically had a point for like partitioning the 12 volts however they felt like, in case they didn't want to share part of the VRM's power from the PCIe slot. So that was a really nice place to solder to, but the GTR doesn't have that. I guess I could try solder onto that pile of garbage, but actually it doesn't matter because the wires are a mile long anyway, doesn't it? So you can just go on top of that. I don't know why I bothered with the rear at all now. This pile, yeah, that actually melts. Come on, attach. Ouch. Wire's hot. I'd like to get it like there. That looks like a nice. The only part of this getting warm is the wire. Instead of the entire thing, which is what should be happening. Attach. Please attach. I'm gonna call that, I mean, that's garbage by any normal metric for how good your soldering is, but it you know, it's in place. I don't think it's shorted out against anything. So yeah, and yeah, the wires are just, the lengths don't align at all, so that's great. That's what I was trying to avoid, but because basically, I'd need to trim the black and the red and the yellow lines to align with the length of the white line, which is just because the white line is pulled up a bit higher than the others, but oh well, what am I gonna do about that? Because, yeah, to hell with it. I guess I could have pulled all of the wires to sort of upwards. Actually, no, that would have made the problem worse, because then the black and the red would also be different lengths. That connection, that 12-volt connection just looks like utter garbage. It doesn't show up that great on camera, but it is really bad from my point of view. But it should be enough to just fire it up for now. So, let's go grab an extra power supply and fire this up. Go. So we'll be firing it up with the little 550 watt Cooler Master, just to make sure that I don't actually, I'm not 100% certain that I'll need to pull the enable pin high, so I'll try fire it up now. Why do I have European power plugs here? This one. Oops. That's not turned on. Good. So we'll just take the SATA connector from that, plug it into here. And at this point, this should turn on. We'll check that with the multimeter. So, power supply is on. This isn't on fire, so at least there's no short circuits on it. Yet. But we're not getting oh, we are getting voltage out. Damn, I'm lucky. Oh no. Did it short against something? I think it works. Like, it fired up. Yeah, I'm getting voltage. Damn. That was way easier than it should have been, just the SATA connector. But that's because I pulled it off the PCIe slot. The enable pin must be pulled to that, but that is awesome. It's running. It's running, it's running, it's running. So there's the multimeter. Falling over because I really don't have anything to... Where is the box? Oh, right, the camera is sitting on the box, so I can't use that. Tub of Plasti Dip. Meet multimeter. Oh yeah, you can read that. So, power supply is on. And if we just probe the output capacitor bank on this thing, we should see voltage, which we do. And wait, I have the probes wrong way around. That would be reading negative. Yeah, 1.15. What did I tell you? That's perfect. It is getting hot. Yeah, pretty damn hot. I want to check if we have all the phases running. So I'll just turn it off for a bit. To let it cool off. Turn off the soldering iron. Though we will still be soldering on a feedback line, but that'll be, again, on the back of the card. And then we'll need to attach the 6-pin to this pile of crap. I hate my soldering. What was I getting up for again? Right, yeah. The return of the extremely miserable oscilloscope. I really wish I had a nicer one, but this'll have to do for now. So, can you read that? Kinda. So basically the idea here is, I'm going to be probing the high side MOSFETs, and if they're running, we should be seeing it on the scope. So I'm just going to ground it off of there. This end is for the probing, and let's fire up the VRM again. And I just got that caught. And this auto ranges, so hopefully the auto range won't just completely... That's wrong. There we go. Oh, right, yeah. Yeah, so that one's running. Stupid... Yeah, I don't know. Is it telling me the... Yeah, okay. The voltage reading is completely wrong, though. This phase is running. That phase is running. This phase is also running. That phase is running. That phase is running. Damn, hell yeah. That's one thing that I screwed up on the original reference RX480 VRM, is I only had these 4 phases running, and this one was running really, really dodgy. But here we have all 6, which is really, really good. I'm really happy about that. I think it might be in diode emulation mode. That might be why it's running so hot. So that's great. This fires up. That's awesome. It works. It works, it works, it works. And we have all 6 phases running, even though I'd really like to get the oscilloscope to read the voltages properly. It is in DC, and it is on max, so I have no idea. I really have... Wait. Oh, the probe's in 10x. I'm an idiot. That's why. The probe was in a ratio, so... Okay, so it's still... Yeah, it's still running. It's still putting out heat. This thing is getting really warm. I'm not particularly concerned, but something went wrong. Oh, I think they put it out of automatic timescale. Yeah, it's outside of automatic timescale. Let's see. Fortunately, this... Okay, I'll restart the VRM. There, so that's the VRM turned off. When we fire it up... Yeah, no, it's running normally. It's just the automatic timescale on this thing. I mean, the manual timescale on this thing is trash. And I have the voltage divisions set too low. Yeah. So 4 volts per division. And we're seeing it, yeah. What about this one? Yeah, they're all running the same, so... Nothing wrong with it. It's probably just the voltage controller being really, really confused about why there's no current going through the VRM. So, yeah, let's turn that off. Well, it works. So that's a success. Now I think we should hook up voltage control to it. This is really hot now. Since I do have the power supply here, let's grab a fan and just point that at it. Actually, it might also be running so hot because just today is hot. I'm getting cooked alive in here. It's so warm today in the UK. It's like, I have no AC, and the room is facing west, so cool. Actually, I'm gonna cool myself. Yeah, this is still hot. Oh. Well, I don't actually, like, I don't have a spare heatsink that I can just hook up to this right now, and I don't really care about finding one. Like, if I can put my finger on the VRM, it's not hot enough to be worried about. If I instantly got scorched, then that's when I'm starting to worry. I think the VRM was probably running, like, in diode emulation mode, which would massively just dump the, that would ruin the efficiency. There. Yeah, that's like acceptable temperature now. So, okay, so at this point, it fires up, it runs. It's not pretty. You have no voltage control. We do need voltage control, and I'm actually going to rip that off of the other RX 480 I did because the layouting on this thing is the same. I think to finish this video off, I'll hook this up to the GTX 570 I have, because that thing is in a sort of constant state of available for power boards. So I could hook this up just to test run that it fires up, and we're just not going to hook it up at all safe. We're just going to use the absolute bare minimum of connectors to get the thing to fire up. So yeah, but this turns on, so that's a good thing. I still don't like this whole dangly connector thing. But we do need to attach this at this point, which this is going to be hard. Because there's, I mean, yeah, there is the option of just attaching to this blob right here. You know, but, except even attaching to that blob is really, really difficult. Well, more difficult than it should be, just because the wiring isn't big enough, so... Yeah, well, I'll just strip the heat shrink off of this first and go from there. There we go. So yeah, that's a 6 to 8 pin converter from some graphics card, I don't know which one. cut this, and again, I'll go for as much length as possible. Learning here. Last time it wasn't long enough, so... yeah. Go. Ta-da, and there we go. So now we have our connector for both juice and ground. So I am not sure how to pull either of those, where to pull them out from. I mean, 12 volts would be super convenient if I could hook it up to just the capacitors right there, but again, that has worked so good so far, so yeah. Also, I said I should have this hooked up through a choke. So I have to redo the entire 12 volt thing. I need to build the 12 volt properly. There's just nothing else for it at this point. So I will try to get through the stupid capacitor legs. I did turn this off while we were testing this, so give it a second to get up to temperature, and then we'll be back to making zero progress, or possibly breaking the board. Okay. There we go. That looks okay-ish, I think. I'm not sure. I'm never sure. So the thing I find really odd is... So one thing I find really odd about chokes is when you look at GPU PCBs, right? The chokes you see for filtering are like tiny little things. Like absolutely minuscule. And then you have the power chokes, which are like huge monstrosities. Right, like this. But there's not really that much copper in this anyway. And this has 3 18-gauge wires. So if the current going through this has to go through that, how does that work? That's just something, I mean, I guess this has enough surface area and mass to dissipate all the heat it builds up. But, you know, I'd expect the conductor in this to match the conductor of this in cross-sectional area, and it just doesn't, so... That's just been always something I mean, it works. I've never seen a choke catch fire, but... yeah. I've heard of chokes catching fire on reference RX 480s on liquid nitrogen. If you tried to push too much power through the reference VRM, it would, like, one of the choke... well, the VRM was fine, but the filter choke on the 6-pin, that thing would actually start smoking because it got too hot. And really, chokes don't burn out. It's just like the stuff they use to insulate the insides of them just melts. So, yeah. I need a good 12-volt connection point. And somehow put this choke on it and make it... yeah, no, that's not happening. That's just gigantic and awful enough. You know what? The more I think about it, that might actually work. just sticking that right there. And these are chokes from the GTR. These are from the memory and the auxiliary VRM. Bend the legs outward a little bit. Get them flatter. Damn it, bend. I'd like to not break the casing on this, but... and see, the thing about the reference card is there was a point right up here, which was straight 12 volts. And that was super awesome, because I could just go and I had 12 volts. But this doesn't have that. So that makes my life a lot harder. I guess you could sort of... that looks awful. That just looks really bad. Like having the choke hanging off the back, that just... I don't like it. It looks like, because it'll also be really impractical if you're trying to attach it to anything, and And then there's the whole, like, there's components everywhere, whereas I'd ideally want to have the choke hanging off of the edge of the PCB, but that doesn't seem to be doable. I could sort of float it in midair over here, but it's still just, it's still really not ideal in my opinion. Either way, I do need to move the yellow 12-volt line anyway, so let's try to pull it out without having to cut it out. Yeah, now it's not going to want to let it go. There. Oh, yeah. So that was never well attached because that just came out way too easily. But how on earth do I get this choke in place such that I can still reach it with 12-volt wires? I'm really not sure. Because these points weren't right here. That would actually be where I go for, because this sort of, like, it sort of dodges them. But just about, because I don't want it touching a ground plane either. I mean, technically the outer casing of a choke isn't conductive, and we can actually test that. And that's intentional. The outer casing of a choke isn't supposed to be conductive, because if it was conductive, the changing magnetic field inside the choke would create currents in the actual core of the choke, and that would create a ton of useless power loss. And this is in voltage again. Yeah, okay, so that's not conductive. That's cool. I guess I could just slap it on anywhere then. Like that. But I just don't like the idea of having like a giant cube like that sticking out of the PCB. It just doesn't seem right. That's the nice thing with cards where if you're doing cards that aren't by the PCIe slot, you have all your chokes still on the card, because you're using the stock 8-pin and 6-pin power connectors. So you don't have to worry about the whole, oh, there's no input filtering, but oh well, I'll figure it out. Well, I mean, I figured it out already. It's just a case of let's hook it up to a capacitor leg, because, you know, I love soldering onto those. And the ground leg, for some reason, wets much easier. Now I got both of them. Yeah, so that's a short circuit. Oh, kill me. Come on. Cool thing is, if I tried to boot this right now, then what would happen is the power supply would just trip short circuit. Well, actually, nothing would happen because the 12 volts aren't connected, but there we go. Fix that. But that 150 watt soldering iron, I've actually, with the 150, I've managed to desolder capacitors completely, just push them through, but this is a 60 watt, and so it has a hard time doing just about anything. Unfortunately, the 150 is also massive, so doing anything remote, like this is not accurate soldering by any stretch of the imagination, and yet the 150 couldn't do this at all. So the 150 is for, like, attaching power lines. That's about it. And actually, I think its intended purpose is for, like, soldering copper pipe. So, yeah. It gives you some idea of what kind of accuracy that thing gets. But it works really well when you have something that has a lot of, you know, that is hard to heat up. But there we go. I mean, it's not falling off, so I guess that counts. Oh wait, nope. Yeah, that's not attached. Watch. Dry it out, and yeah, it's coming right off. Why can't you just stick? Ugh. Actually, like, you can tell that nothing is happening because the heat output on the soldering iron hasn't changed. is still at the, because it does have a little indicator. So it's at 1 bar, 2 bars. I think it might actually be wetting at this point. And it's back down to 1 bar. That just never gonna attach, is it? Yeah, no, it still has the same problem. It never makes a... That's not even like... I shouldn't be able to touch that, quite frankly, which is ridiculous. That's just... Capacitors suck. For soldering. These are 12 volt as well, but if I try to... That, no, that's dumb. I guess I could try scratch the power plane, because if I remove some of the PCB mask here, then I should be able to get through the solder mask. To remove some of that, I should be able to get it straight copper, and that might work better. Might being the key word, because that tends to go just about as badly as the actual capacitor light for me most of the time, so we shall see. Maybe I can get it to connect to that, but I doubt it. Come on. Let's see. This generally doesn't go well for the same reason that capacitor legs don't go well, because it just doesn't... Yeah, it doesn't heat up. You can never get it up to temperature, because basically, to get solder to wet, your two surfaces have to be at the same temperature, or at least above the melting point of solder. And that just doesn't happen to me. Might actually work, maybe, if I'm lucky. When I soldered, when I did the GTX 570, I did the entire power plane of that thing, the V-core and the ground connections, all with the 150 watt, and that's great. Because after you get the solder to wet once, it's actually really easy to add onto that, but for some reason, whatever they ship cards with doesn't melt at all. So... Nope. Yeah, that's not connected at all. Just keeps coming off. Ah, can't believe it. I think I might actually pull out the 150. Actually, no, I won't, because there's not enough space to work with that, with the camera and everything. There's just no way to hook it up to that. Like, I can sort of make it work if I try here, I bet, but... Again, I said this is just... It's like, I wanted to keep everything on one side of the board instead of two sides, but... I guess since I don't really have a choice at this point. There. See, that attaches... Well... No, that's still dodgy as hell, but... It's mostly because it's all solder... all the... The stupid display ports went over there, then it wouldn't be such a problem. This is actually going easier, because, I don't know. It's like the fresh solder for some reason actually melts compared to whatever they ship cards with. There we go, that's solid. So if we now attach this to that, and then we'll do a test if this still powers on. Man, that looks dodgy as hell, but... So does everything else about this project, so... That's not really worse or better or anything, so... Oh, yeah. Yeah. Okay, well now it's happening all the time. This 12-volt one is gonna look awful in a few seconds. Never get a working angle. Not ankle. No, shrunk that down. Through this end. Okay. That's not... How does that happen? It looked perfectly good. To me. Admittedly, I can't see anything either. Starting to think I should just try to, like, strip more of the coating, wrap it round, and then try to solder it on. That might actually be a good idea. Strip more coating, wrap it round, and solder it on one big blob, and then I actually have more plate space to connect these as well. It is so hot today. At least the sun is dropping down a bit. There we go. There we go. That's all bare, so we'll just wrap that around and try to make it just into a hook, and it's the best. Yeah, I'll just hook it around. Come on. This is probably garbage. Yeah, okay. This should work at this point. It might. Multi-strand always falling apart. Not really its fault, that's kind of what it does when you pull the insulation off, but it doesn't change the fact that it's not annoying. Twist it first. Hopefully it'll keep it together better and then it. There we go. Okay, and now it'd be great if I had more hands. Okay, now this will work. Yeah, that's solid. That worked. Got it. Okay, perfect. Useless one. Yep, that looks solid. There. So now we have filtering and we have a decent place to solder it onto. So that looks like that. It is a great big monstrous blob because the wire does, you know, hook around that leg. And let's see if it's if it blows me up now. That was quite a bit of rework, even though it took forever. Let's fire it up. No fire, no smoke. That looks good to me. Let's check what the voltage output is like. PSU hasn't shut down yet. Yeah, it's getting warm already. 1.15, perfect. It's still running just the way it should be. Actually, it's probably warm because I was soldering onto it. So now let's hook this up. And this needs to be hooked up to ground as well. So I think what I'm going to do with this is I'm going to get ground from the back here because that actually, I could hook up ground off of the touch the choke. But I'm thinking, we have all these ground points which belong to the display ports, right? We could use those, because there is like this there's a massive ground plane around this outer edge. I mean, it goes from here to, like, it just goes all the way around. So I'd expect that ground plane to have a decent connection to the ground plane right behind the VRM. So I'm gonna hook up to those 3 points right there-ish, like so. And then we can get 12 volts on the choke right there, which isn't gonna be an issue at this point. Theoretically. Okay, so let's strip all of these and go for it. That's one. Two. Three. Four. Come off. There we go. 5. And last one. Tin them all, and then we attach them all. This will be the... Yeah, at this point, I mean, it's not good enough to power a GTX 570. Like, the VRM is actually fine. It would power a GTX 570, nobody's business. The 6-pin isn't enough to power a GTX 570. Technically, I'm going to be connecting it up exactly like you'd see an 8-pin. So 3 ground, 3 12 volts. There's no sense pin on this because, yeah. This thing is actually really unsafe because of that, because on a theoretical level, this will boot up, right? You could theoretically try to turn this on just off of the SATA power connector, regardless of what's on the other end of this. So, if you had like a GTX 570 hooked up to this, and you only had the SATA connector, it might actually burn out the SATA connector just running stock, just booting up, which is why you need the 8-pin, so, yeah, let's get that hooked. I mean, the 6-pin, wired like an 8-pin, hooked up. There we go. Okay. The last couple. My hand is getting really hooked here, but go. Not good. And last one. There. So those are all done. Let's see how these ground points are. Oh, these are super easy. What the hell? That should not be that easy. Okay, that's good. That's actually really good. Surprise, though. So, let's hook these up. And make sure that I have the orientation of the 6-pin correct. Otherwise, this will be really painful. Speaking of that, I might want to... I'm gonna bend the thing apart a bit, because otherwise it's gonna suck for... Because I do have a sort of like half the 6-pin is going on one side of the PCB, the other half is going to the other side, so I need to bend it out to get it to do that easily. These are all bent now. Go. And let's do this one. That did not attach. I need this to stop running around. The choke made that worse. Let's see. Where are the these guys. So these guys are actually, like, I've modified these to basically hold stuff in place for me, because I run out of patience with having stuff run away. And that just popped apart. Fine. Together. I should get some kind of extra hand, like second hands thing, but or some kind of holder thing for PCBs, but I don't know where you go get that. Honestly, it's like, where the hell do you buy those? Okay, there we go. And the blue tack. Yeah, okay, that'll stay in place now. Great. Right, this is really close. Go. Ow, my fingers. Now that looks solid to me. Let's get this one. Yeah, that's pretty solid. Let's get that last one. Ow. Right fingers really got it in that one. It has to be some kind of like soldering gloves or something. There. That's all the grounds attached. They don't seem to want to go anywhere anytime soon, so I'm gonna call those solid and flip the damn thing over. And now hook up these. Oh, this is awkward. The grounds are way too long compared to the power lines. Oh well. That's great. Technically speaking, I shouldn't be using the SATA connector at all in parallel. Like, you should have one choke per power connector. But, we're just gonna ignore that. The reason why you don't want to do that is technically there could end up being a small voltage difference between what goes into the SATA connector and what goes into the 6-pin. And then you get a little bit of current going back and forth between those instead of... which you don't... Generally, you don't want that, but... For my purposes, you know... abiding to specifications for everything properly is kind of optional. Ow. Ow, my finger. This is actually a lot harder than I expected it to be. At this point I was hoping it'd be easy because it's already on the choke and all that, but... Ideally I want this board standing up because that's where I have the most space to connect on, but... Oh, this is going to be one of those also awkwardly sized atrocities again. That I keep building. Oh well. Yeah, like that. That'd be perfect. If I could get you just like that, and then, well, actually, that would suck. You know what? I'm gonna disconnect the one I just attached. Move it over a bit. Because this one is the outermost one, so I want to really have it on. These things are really hard to manipulate. That like there, and then pile on the other ones from the side, sort of. That is a really dodgy connection. Okay, that's better. Barely. There. Third, second. And let's get one last. And let's get that. Oh. Oh, I'm an idiot. That was a freaking outer one. I should have checked which one I was attaching. Oh. See, this one is the outer one, so I should have attached this one first. Well, before that one. I kind of suspect this choke is going to end up being a hotspot just because my soldering isn't great, so all the current going through there is just going to heat it up. But if it works, it works. That's all I really care about. Yeah, if I trimmed the wires, then that'd be like... It'd be so much easier to do this, but this one's actually coming off. I might end up trimming this one and leaving the others alone. Actually, I could just move this one onto one of the other one, like next to one of the other ones. That'd be problem sorted, I'd say. Yeah, that's what I'll do. I'll disconnect this one temporarily. That'll make it easier to work on the other end, and yeah, see? Much more freedom with this one. Wish I could put it just under the others, but that's gonna be... no, that's doable. Just about. That is a terrible connection. Yeah, okay, that just failed actually, so of course that was terrible. Try to get some stabilization on this. And here we go again. Attempt number 2 to burn my fingers off. That connection still sucks. Yeah, that is just... This keeps moving, and how much what I would give to grow a third arm. My life's so much easier. Okay, there. That's kind of attached. There. So let's hook it up completely again. SATA connector and all, just to make sure that I didn't screw anything up. Well, it won't boot without the SATA connector, so that's non-optional. But the 6-pin is, and I want to check that the 6-pin is wired correctly. So yellow to yellow, goody, and burn my house down in 3, 2, 1. House is not on fire yet, so that's working. Let's check the voltage. The fan just gave me an illusion of seeing smoke because I'm just so ready to see it on the power supply. 1.15, still working just the way it's supposed to be. So that's perfect. So at this point we need to attach voltage control, and it'll be a fully operational power board. I mean, technically at this point, if you just need 1.15 volts, then this spits 1.15 volts right out, and you don't need to do anything at this point. But 1.15 volts is basically completely useless. So we need to give it some voltage control. And to do that, we will need a potentiometer. A 120 ohm resistor to limit the minimum resistance to ground. Because basically this is just a good old-fashioned feedback pin mod. So I'm just going to do it the usual way for any kind of physical volt mod. Where I'm going to pull... So what I'm going to do is I'm going to have this middle, the actual output of the potentiometer. That'll be going to the voltage sense pin of the... Wait. I can't really get it into the angle. So middle pin on this will be going to the output, to the feedback line of the IR3567B. The two lines on the sides, one of them will go to V-core, one of them will go to ground. The reason why I'm having one to V-core, one to ground, well, the one to ground, if we go towards the ground one, it's going to increase voltage. If we go towards the V-core one, it's going to lower voltage. Now, if I'm not mistaken, no. IR3567Bs use a zero resistance sensing circuit, normally. So, whatever I hook up, it's gonna still, like, the minimum voltage output on this thing is never gonna go below sort of 1.15 volts. Even after I attach this, because that's a normal way this thing would be wired. On a GPU, you would have zero resistance to V-core and infinite resistance to ground. From the, well, no, you wouldn't have infinite, but the resistance to ground would be really, like, actually, it gets messy. It gets messy. I'm not going to bother explaining it because basically, since you have the, if you have the VRM turned off and you measure the feedback resistance, the feedback to ground resistance of an IR3567B, you're just going to end up measuring the electrical resistance of the GPU core itself, which just completely screws over the measurement because GPU core electrical resistance, like the GTX 1070 has an electrical, a off resistance of like a couple milliohms. You can't even measure it with my multimeter. Whereas the 480 is like 1 ohm or 2 ohms or something like that. So it's an absolute nightmare to try measure that. But I'll look up the IR3567 datasheet. And we'll figure out which pin it is. And I'll get the... I'll grab the 480 power board, because there I actually had to, what ended up happening is I traced through the board onto the back of the board, because on the back of the board it is much easier to hook up your voltage sense lines, hook everything up. Oh yeah, and I forgot to reattach this. Should do that, shouldn't I? Wonder, could I just maybe attach it to the screw hole like that? That'd be easy. I think I'll do that. Yeah, let's do that. I just hook it to the screw hole. Yay, see? Screw holes, wedding! Oh man, this sucks so badly. Like, I can feel the iron freeze into the solder. Like, it just solidifies into... Yeah. Small iron, big PCB, lots of copper. Not happening. If I had if they made, like, if 80 watt and 100 watt regulated irons weren't so ridiculously expensive, I would jump for one in, like, I would grab one in them instantly, but they are really expensive, so this is the best I can do for now. There, that looks even worse than ever before, but hey, deal with it. Yeah, that looks just atrocious. I really should trim that down. But oh well. This already just looks like something you'd want to burn your house down with before you'd think it could power a graphics card. Anyway, datasheet. I have it open, and the pin we're looking for is pin... This is not going to be fun, 6. I do have a magnifying glass, so I'm just going to check it out with that first. I'm going to try eyeball it. This is such a dumb idea. Kind of wish I didn't plasti dip the entire 480. By which I mean this thing right here. There! So that's the 480 VRM, and as you can clearly not see, I haven't soldered anything up here. That's soldered. Kill me. Pulse kill me. So that white line goes somewhere over there, which on this board, I'm really lucky XFX is using basically a copy of the reference design. I mean, we can even see those SMDs are the same place. What is that going to? Ooh. Oh. Okay. That's not going to be that hard. It looks like I might be lucky here. I might be really, really lucky here. This might not take that long after all. Where's the current clamp? We're going to use that to hold the PCB up. This actually works. I need to get like some kind of padded clamps to hold PCBs for me. This is getting ridiculous. Hey, stands. Put this into resistance mode. And, well, actually, I need to first figure out where pin 6 is on this pile of garbage. I think pin 6 actually has, like, a test pad on it, which would be super convenient, but not 100% sure. 1, 2, 3, 4, 5. Oh, this is so hard to... I hate voltage controllers. Seriously, way too small pins. 1, 2, 3, 4, 5, 6. Okay, I think I found 6. And the shadow makes it nearly impossible to see where 6 goes. 6. Oh yeah, 6 goes just straight to the PCB. Okay. That is really awkward. Okay, where is the box cutter? We're gonna scratch off ever so slight amount of PCB that. And holding that. So that I can hopefully get a better point to gauge where pin 6 goes. Okay, I think that might be enough at this point. This is in resistance. I need to see 0.
We can change. We can change.
The decision is made. The process has begun.
That's my go. Probably not the right thing. Is it always in the... Oh, my fingers are there. Great, so I haven't gone through the mask at all. If I had a schematic, this would be so much easier, because I could literally just check what on earth... Like, there's a thingy here, on this side of the PCB, which I know for a fact is hooked up straight to pin 6. Except I have no idea which part it is, so I need to trace through from pin 6 to that part, and that's just... ugh. Also... Yeah. See? That's 6. At this point, I'm on pin 6, and I somehow need to measure a pin all the way on the... And it is dark again. Come on. Move over. There. Yeah, so pin 6 is right about there. I think. Wait, 1, 2, 3, 4, 5. Yeah, that's 6. 6 goes. Where does 6 go? Oh, 6 goes to... Oh, I was actually scratching on the wrong thing too. Perfect. Easier. I'm gonna try force this in. Try drive it too. Yeah, I think I got it. Yeah, so stock resistance on this is 97 to V-core and 180 to ground. I'd like it if the resistance to ground was higher. I'd prefer that. So, okay. So I've managed to stab the correct thing. that thing would actually kind of force down a bit. Yeah. So now I need to lift the damn PCB with that stabbed in. Like that, maybe? And I think it's that. Yes! I am a lucky guy. It is in... Yes, I found it. Found my target. Perfect. So, sort of... There, kind of... Whatever I'm stabbing over there, that's what I wanted to find. That's 0 ohms. Perfect. So that was this little thingy, and I should use a smaller tip for this, but at this point I kind of don't feel like changing tips. So I'm just going to go for it. And we're going to make... So for my other RX 480, I made this very nice wire combination, which I'm going to remake again, because I personally really like the look of that. And it makes sense. White line to feedback, black line to ground, red line to voltage. So I'm going to remake that. How much? Though I do remember that not being long enough last time. How long is that? That's about... Okay, I'll get myself some more. Perfect. Where's the snip? The thing is, I'm gonna solder these on first, and then I'm gonna actually, like, bring them together. Sorry about that. Because otherwise, it's like trying to bring them together separately is impossible. Let's get this one. Length. Should get some kind of spool holders for the spool in that. Okay. There we go. That's about half a meter of wire. Which once I twist it up, it's actually going to be smaller. So hopefully I'll end up with enough this time, because on that other one, it's not long enough in some situations, and I don't know how long the wire was when I started. So yeah, that's a great thing to do. There we go. Let's get the black. Perfect. And that's the last one. Now I'll just check that they're all roughly the same length. And they are. They're actually almost exactly the same length. From end to end. See? Barely a difference. Perfect. So now we can start hooking them up. So I'll start with the white one. And I'll do the ground one. I'll do the resistor on the actual potentiometer end. And yeah, that'll be it. It'll have voltage control after that. Ouch. I think I overdid that. Okay, no, I didn't. Thing about having a fresh box cutter blade is I tend to cut the actual copper strands of the wires themselves, which sucks, to say the least. These tin so much easier thanks to being smaller. Okay, let's see. I need to do both ends, otherwise this will be a nightmare. There we go. That's tinned. We can hand. I'm trying to do it with the. Actually, I think I really do need a much smaller tip for this. The one I have right now is for like hooking up 18 gauge wire. This really isn't. Yeah, this is a dumb idea. That is a really dumb idea. Okay. Turn off the iron, let it... Oh no, but I can't do anything while I'm waiting. I should get a second iron so I can have them on 2 different tips at any given time. And then if I ever needed to, I could get like 2 irons for double the power. Combine them together. Oh well, I guess I'll strip the other wires while I wait for that to cool off, which is going to take forever. Well, I'll only wait for it to cool off a bit, and then I'll actually use wires to take the tip off. No need to bother with, you know, actually waiting for it to hit room temperature when I don't need to touch it. There we go. So black line done, red line. I guess I could have tinned on the big one. Oh wait, actually the red and the black line are going to capacitors. I need a big tip for that. You can never win. Well, I guess it's back on with it then. I'll turn it back on, tin all of these, and get most of the hookup done, and just the white wire is the one that's going to some. Actually, I could probably, if I'm careful. Yeah, I can just about make that work, even with the giant tip. Okay, we'll do it with the giant one, just because I'm that lazy. Well, I'm more impatient. I don't want to wait for the damn thing to cool down. So, we now need to pull capacitor side. And so we have, like, if you really wanted to go super accurate for your power board, is you could have this red line go to the capacitors on, like, the back of the GPU core of whatever GPU you're hooking this up to. But that takes more work, and you'd have to set that up every single time you're setting this up, so I'll just set it up to pull off of here. Now, if you really wanted to make it fancy, you could also have like a switch that would then switch if you're pulling from the board or a GPU or something. But for now, I just want to get this to fire up and measure and be controllable. So I'm just going to pull it straight from the board, because that's the bare minimum you need. So, if I'm not mistaken, that leg is ground, and the other leg is V-core. Let's check. So, resistance from one leg to the other, 80, 90, it should be about 97, 95, okay. That leg to ground is 0, this leg to ground is 90-something. Cool, so one of those, the one that's 90-something, that's V-core, so we'll put the red line on that, and we'll put the black line on the other one, because that one's ground. Way too much solder on the tip of that. Soldering to capacitors sucks. So actually the output ones on this card aren't that bad. Don't take as long as all the other ones do. There, and plus this isn't like a super important connection, so if it's a bit dodgy, I don't really care that much. These are both really, like, long, so I'm going to trim the ends off a little bit. Where's my wire cutters? There we go. And attach that. I'm not sure where I want to leave this. I think through the back there, yeah, that makes sense. There, that's attached. Oh man, little wires. So easy compared to the monstrosities I usually have to deal with. I mean, when I'm doing the 8 gauge stuff, it doesn't really matter because I'm using the 150 watt, but yeah, that. There. There. That's not going anywhere. The wire itself is actually not that strong, so I don't want to pull on it so much as I would on some of the other connections like the power lines, which, quite frankly, like, those are 18 gauge wires, so they can take it. And it's more concerning if the connection for those breaks than if the voltage control breaks. That's not the biggest issue. I could have voltage control not working. There. Also tinned. This one's also overly long again. So I'll trim that down. And hook it up to the other leg. Right. There. Yeah, that's so much easier than the other ones. There. So those are those two hooked up. Perfect. And now we just need to do the white line, which needs to go to a little SMD over there. And that is gonna suck. But we're gonna do it, even with an oversized tip. Like, really, really oversized. This is like... To get some light on this. Luckily... that's too much solder on there. Luckily, because that's actually such a small connection, it doesn't need a ton of heat to work. There. That's actually attached at this point. And because that connection is really tiny, like really small, I'm gonna plasti dip that right now to make sure that it doesn't go anywhere. So let's get the plasti dip. Pop that. Where's the... I had a flathead screwdriver somewhere. Oh, there it is. Pop that open. Get the paintbrush. Just brush some plasti dip right on top of that. It's the best way. Oh. Alright, that's not going to go anywhere. And if I wanted to ever remove that, plasti dip comes off a lot better than hot glue. Which... you know, that's the other alternative for this kind of job for fixing, is using hot glue, but hot glue really doesn't come off as easily, so I prefer to use this. I'll do both of those as well, just because the wires are really not that great. There we go. There. And now we need to wait for that to dry, which will take a while. Because the layer is pretty thick. So I think we'll prepare the potentiometer, and hopefully by then this will be all dry. And I can then attach that to the potentiometer, and then it'll have voltage control working. We'll also have to twirl the wires together. Another thing I want to do. So where did the potentiometer go? Potentiometer go here. And that's the... I can't read resistor values, so give me a second while I check this. Yeah, it's the same thing. So that's 120. So the potentiometers I'm using right now are logarithmic. Because I had the genius idea that, you know, if I had ones that change how quickly they change, they'll be more... Because this is a ratio thing. So it would work, it'd be more linear. And that great idea didn't really work out that great. It's not, it doesn't seem to be worse than when I was on a linear potentiometer, but it's just certainly doesn't seem better. So I might need like an inverse logarithmic to get linear voltage control, which is kind of unfortunate, but could be worse. So now we need to attach the resistor to that, and then once that's attached, we can, well, this won't dry off that quickly, but attach the resistor and then the wires to the resistor, but first we need to twirl the wires. And actually we'll need to trim the red and the black one because the white one starts a little bit earlier than those. And I'll also want to cable manage them somewhere. I need to find some kind of hole to shove them through and zip tie them into or something. So I think I'll put a zip tie through that ground hole over there and run. Yeah, that's what I did on the other one as well. So I'll just do that again. There we go. Right, that's gonna move around everywhere. Come on, turn it. There we go. That's not going anywhere now. Well, not going anywhere. It's a lot steadier. Even though it's tilted a lot. So. There. That's hooked up. How are you guys doing? Not drying fast enough. Oh. Oh well, I guess I'll check the chat and see everything I've screwed up at this point, according to everybody. They really need to do something about the like, there should be like a Twitch chat room app, so that I don't need to reconnect every time I want to check what you guys have been saying in the app. Actually, I know this phone can do multitasking. I should be able to enable, except I don't know how to enable it, which is great. It's like, oh yeah, the phone can multitask. It's just too bad it multitasks when I least need it. How on I have right? Oh, that's how. Right? No, that's not how it multitasks. Damn it! I have no idea how to make this work. I need a text to speech. Yeah, I guess. I guess that would help. Just well, to be fair, my phone does have a browser with desktop mode. It's just the phone turns off, and every time it turns off, and I can't figure out how to change the turn off settings. Which I know that's an option somewhere, it's just, I have no idea where. I don't generally use, like, I have this is basically my brother's phone, which he no longer uses, so I'm like, yo, I'll take it. I'll use it for photos, because this has a much better camera than my usual phone. But, yeah, I have no idea how to use the damn thing, so that works great. It's like, it should be somewhere under power settings. Like, no, I don't want auto brightness. I want to disable its ability to go into sleep mode. Where is that? I'm clueless. There's not that many setting options on this phone in the first place. Where on earth would that... I guess they don't let you do that. Praise Samsung. Oops. How do you calculate the value of the potentiometer? So I'm doing a 3-pin, a 3-connection volt mod here. So I don't actually care what value the potentiometer is at all. That's why I've started doing this. Because normally, if you're doing a potentiometer, you need to take into account the original resistance you have. But basically, with the three connection method, as long as you have a potentiometer that is almost lower resistance than what you started with, it works great. Wait, it's in screen lock settings? I'll try that. I really want the chat working. Controls, general. That's what? Lock screen. Yeah, camera shortcut, screen lock, action memo, wake up, and lock screen, help text. Wait. Nope. Shouldn't it be under, like, power settings, like never go to sleep or something? I guess it might not even just be in the settings of the Samsung phones. I know I can do it on my Gigabyte one, but that's bone stock Android, not whatever the hell Samsung runs. Oh well. Okay, so the plastic has mostly dried at this point, though I do want to put a little bit more on the white connector. Just because that one, like, if that one goes, then it's probably going to rip the SMD with it. And if it does that, then I'm going to be really, like, my life is going to suck very, very badly. Actually, I'll just boost the entire layer that I put originally in, picking it up a bit. Stretch where to it hooks up from, just more surface area it can attach to, the better. There, so that first dry layer will actually help it speed up drying the second one, so this shouldn't take so long this time. Meanwhile, I'll go back to trying to figure out how to make this phone not turn off, because it just forgot everything in the chat room again. Display. Oh, I'm an idiot. Screen timeout. 30 seconds. 10 minutes. Thank you. There, and now I can watch the chat for 10 minutes at a time. Lovely. Phone, this is a Note 3, I think? I think it's a Note 3, I'm not sure. No, it's not an S5, it's a Note. It's a Note something. My hands might make it look like it's not a Note, but it is a Note. It is very much a Note. For me, this thing is conveniently sized. This is like an acceptable sized phone for me, but most phones for me are just like tiny little things. Gonna try. This is gonna be really awkward with the... because I don't think I have a zip tie that can actually clamp those properly. Like the wires aren't... they're not thick enough to clamp in the zip tie. And speaking of zip ties, this one can go, because it's not using it, not useful. There. It's too bad. That would have been cool if that worked. But mostly, it's like, you know, I think I'll rework this into something neater eventually in my spare time. GTX 580 Matrix, I could do that. Mostly because for the GTX 580 Matrix, I can just call on one of my contacts that I have. I can literally just ask whatever it is that I need. Like, if I don't know something, I can just ask, which is really awesome. That contact helped me when I was doing the RX 480 reference board. Because with that one, I had a huge problem with it just not powering on, and I didn't realize I was missing phase drive. So, yeah. So we'll just zip tie this together. That is almost solid again. Yeah, and basically, the idea is to shove that zip tie right through this hole. I'm so glad I'm using such thin wires. They don't move as much. Like, they don't respond to action very much. There. That's what I was aiming to do. Yeah, now we pull this through. There. And pull the black one. Pull the red one. Why is this turning that way? I want it this way. I'm starting to think that that ground line I hooked up there wasn't such a bright idea. I'm gonna move that again. There. That came off nice and easy. Something over. That was expected. Where's the other ones? Yeah. So we're just gonna reuse one of the ones I shortened. If I could make like a fast-acting plasti dip, that would be amazing. Okay, so have the wires pulled through. It would be nice if this was shorter, like if it wasn't sticking out of the PCB as high. But I think this will work. So there we go. Yeah, I think at this point the wires are... yeah, they're not going anywhere. Perfect. That actually worked out okay. Now let's get the other end. Ta-da! There! Locked in place. And the wires, for some reason, are way longer. Should be there. Oh god, I really pulled on that red one. Go. There. That's all the wires managed. Kinda. Oh, yeah. Let's trim that off. And we have voltage control. And this, yeah, this isn't under tension. The red and the black one are kind of tense, but again, they're not on as dodgy a connection, so there. Now we get to twirl these together and hook it up to the potentiometer, and at that point, this will have voltage control, which is perfect. I think I'm gonna end up making a few more videos explaining like the new volt mod method I'm doing and all that, like the 3-point potentiometer instead of the 2-point and all that. But yeah, you know, this was just to show that yeah, it's doable. I can make my own power boards, damn it. This is just yeah. And the thing is, this was nagging me as like, oh, I've started on this project and I haven't finished it yet. And I'm having very little success with actually twirling these wires. I'm gonna release the potentiometer and use this to clamp the wires. They're on one end. They're done on one end. There. There we go. So now I have all the wires, and we can just start turning this, and ideally that should lead to them slowly stranding together. And I think I have to get a bunch of This is not working as well as I wanted it to, but whatever. It's sort of working. You know, I should have maybe zip tied both of them. Yeah, that's a great idea, Billswood. Why don't you use another zip tie, you great big idiot? Ugh. There we go. Yeah, tension and twist at the same time. I'm fully aware that would work best, but thing is, like keeping them all under tension at the same amount. There. There we go. Yeah. Without using this to hold it, it's a lot easier to twirl with just 2 fingers instead of your entire arm. There we go, it's getting there, it's getting there. Okay, now it has a tendency to go together, but don't do that useless wire. She's straight and twisted. I need 3 arms to do everything. At this point. Okay. Not that incompetent. Okay, there we go. Stay apart, damn it. Yeah, it's getting there. I wonder, would heating this up a bit help? I kind of think it would. There. Okay, now it's staying together. I've done this a million times for fans, so it's not like I've never done it. Chat is bullying me, saying I can't twist some stupid wire. There we go. Let's hook that up. So I actually need to trim these again. You know, which is an obvious realization. Because I did, you know, hook them up different lengths. And the black one needs to be the shortest, and the red one is... I'm just gonna pull them to the same length initially. Earthwire fell off. No, it didn't. Earthwire... No. No, it didn't. Everything is fine. Everything is fine. Nothing fell off. Oh. You mean this earthwire? Yeah, I pulled that one off. I'm gonna add it. Jesus. Don't say stuff is broken, okay? I'm gonna be... Like, I just want to finish it at this point. Okay, so... White and red can be the same length, but black needs to be shorter. So that means white, red, black needs to be about there. There we go. Oh, I think I overdid it. Oh well. Go. Wait, this is falling apart. I should have kept that zip tie on there. I should get another zip tie for this, or it's gonna fall apart on me. Wait, what's a flame? Where is fire? I don't see no fire. The webcam might need a fidget spinner. It certainly isn't good at holding focus from what I've seen. Can't focus for anything. Like, can't focus on anything. The webcam needs a fidget spinner. Might make it less useless. There we go. There, now it won't fall apart on me. Let's get the end of this. You know what? I don't think I'm going to hook it up to the GTX 570. I'm just not going to bother, because at this point I'm too tired. And tomorrow I need to do... tomorrow I need to work on the 1070. And actually, I've worked on the 1070 a bit. I've modded it a little. And then I took all the mods off, because I want to do the Cool Laboratory Liquid Ultra video. And then there's like... The card that, like, the 1070 I have just happens to have a 2 milliohm shunt resistor, so... You know, liquid metal works absolutely trash on that. Oh, damn it, I screwed up the black one. There we go. Okay. I am indeed. I can't solder for to save my own life. There we go. And last wire, because of course I left them going. There. It's done. It's over. Oh crap. This is stuck. Okay, I need to get this off again. Oh man, so many zip ties wasted. At least those are cheap. But AHOC has a legitimate I'm starting to run out of Thermal Grizzly Cryonaut again, which is just... I need to get Thermal Grizzly to sponsor me, damn it. It's like... That's like a thing I really want, is Thermal Grizzly sponsoring AHOC. It's because I use so much of the Cryonaut paste. So much. Because it's so... like, I know it's meant... like, they're like, yeah, only use it for LN2, but... It's the best paste even on air cooling if you don't want to use liquid metal. So yeah, there we go. Twirled and everything, and I'll put one more zip tie on it just to make sure that it stops. Oh look, these are already beyond saving, I think. So I'll just pull them off. Perfect. Perfect, perfect, perfect. All great. Now test it. What do you mean by now test it? Like turn it on again? Yeah, I'm gonna do that. I'm not gonna attach it to a GTX 570 though. That was like, yeah, maybe I will, but I've decided that at this point I just don't have the patience. I can't. I cannot be bothered anymore. That ground connection sucks, but whatever. Let's turn this off and see if we have actual working voltage control. There we go. Burn your house down device 2.0. I mean, yeah, 2.0. This is the second one. There we go. Hold that in place for me, and let's fire this baby up and burn my house down this time for real. Well, no, the 1070, it works, it just doesn't work as good as you'd want it to. Like, yeah, it boosts a bit higher and it runs a bit faster, but it doesn't boost, like, it doesn't free up the thermal limit as much as on other cards, which have 5 milliohm shunt resistors instead of 2 milliohm. I'm not on fire! That was all the way on the wrong end. So, where is the multimeter? In my lap, of course. Of course, it was in my lap. So, let's put that in voltage control mode. Hop. Can you see that garbage? Of course you can. So, let's measure. Let's measure, let's measure, let's measure. I need a ground point. That's not grounded at all, is it? I need to get alligator clips for my multimeter. So let's see, I can just force it into one of these. Can I? Please be kind enough? Oh, okay, that worked, kinda. There, so we're grounded off the HDMI connector. And we have voltage, yeah, see? 1.4, so that's normal because now we're all the way on the left side. I mean, on the V-core side of the potentiometer. Now let's slowly turn it up. Yeah! It's working. Yeah, okay, it actually speeds up. Yeah, I shouldn't have used a logger. I need an inverse log. I need inverse log or a linear one. It's just too bad. Max voltage is 1.96. That's workable. That's workable. That's definitely workable. Yeah, but it speeds up the higher you go, and this multimeter really isn't that fast. So I've screwed it up. I shouldn't have used... Yeah, I need like inverse. Because the problem is, it's just like visualizing the way the electrical resistance affects the voltage is really hard for me for some reason. I can't wrap my head around it. So I was like, yeah, logarithmic will work. Nope, I should have gone for inverse or linear. So I'm an idiot, but hey, we have a working power board. Ouch, 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 ouch. That was a stupid idea. Oh, my finger. That VRM is really, really hot. Ow. Ouch. It must be running in diode mode, so it's burning all the power on itself. So that's the problem, right? You run a VRM like this in diode mode, and what ends up happening is it's trying to unload all of the power that's going into it, and it unloads itself on itself. So all of the power that would normally go into the VRM into the GPU, yeah, it's burning off on the low side MOSFETs. I'm like 99% sure they're in diode mode instead of being used as MOSFETs. And diode mode is like the worst efficiency possible. But it works for low power applications, because in low power applications, turning the MOSFETs on and off actually costs more power. So, yeah, but, turn this off. Well, yeah, no, the VRM needs to, like, it pushes current through it, so it ends up burning it all on itself instead of, like, normally there'd be a GPU. The current goes all the way to the GPU and gets used up by the GPU, but here it's all being used up by the VRM itself, and the absolute nothing, like, the basically zero resistance of the actual PCB. So, yeah, I'm just gonna cool that right off, but it works. It works, it works, it works. That's a good thing. Succeeded. I don't believe it would, like, overheat and catch fire, but yeah. Running a VRM with no load on it is generally not good for the VRM, to say the least. Michael asked if I could hook up the opposite way, like, in reverse instead of... It doesn't help. I tried. I already had that idea. I was like, okay, it's a logarithmic one, so if I just flip it around... no. Good idea, but it doesn't work. Yeah, no. No, I can't think of a way to make it work properly. I think it's a inherent flaw with the 3-connection method is the resistance is changing faster than normal, because you're basically changing both sides of the both sides of the VRM's there. Now it's acceptable. Now it's touchable again. Yeah, so doesn't need a lot to cool it off, but yeah, the driver ICs got seriously hot, which makes perfect sense because those were the... Yeah. Now it's room temperature basically again, which isn't great because room temperature is like 30 or 28 or something. It's so hot. I'm melting here. So yeah, that works, kinda. I'm kinda concerned about it getting so hot, considering I am powering the drivers off of, like, feeding the drivers 5 volts. But, you know, without hooking it up to a card, you know, there's no better way for me to check. Also, about burning yourself with soldering irons, I know all about that. When I work with that 150 watt, basically every couple hours with that one, I burn myself pretty badly. That's how I discovered I taste like chicken. There is a fixed resistor to ground. This is there to basically limit how much max voltage. Maximum voltage, depending on what I put here, max voltage goes up and down. If I wanted to lower minimum voltage, I would actually have to modify the existing circuit on the board itself. But the problem is, right, as I slide this around, then initially the resistance changes very slowly, right? And the voltage is like, so in the 1.1 volt, 1.1 to sort of 1.4 volt range, it's changing slowly. And then it changes faster and faster and faster and faster and faster and faster and faster as the voltage climbs. So in fact, I would need an inverse resistance where at low voltages, it changes quickly. And at high voltages, it changes slower. And it doesn't matter which order I put them around in, because it's always going to be that same relationship. Because basically it's like I need an inverse logarithmic to get the linear voltage control that I want, which I didn't realize because I'm an idiot, so yeah. So, yeah, that's it. That's the disaster of a RX 480 GTR VRM converted into a power board. I'm really happy here. It's way more successful than my first power board because there's 6 phases and there's 6 phases running. it's powered off of 5 volts instead of 12, which I'm not sure that actually... I'm not sure if that makes as much of, like, you know... I don't know. I want to experiment with that, and I certainly can. I mean, it's... Like, at this point... Well, no, I can't actually just pull this 12-volt line from there, but I could just take a 12-volt line from just about... Ooh, this one fell off. Why does this keep falling apart? Wait. Oh. Great. Perfect. My soldering. I think I'll have to hit it with the 150. Like, to get those wires connected properly, I'll have to do it with 150. Actually, that makes me suspicious of that whole connection as well. I think at this point I'll just call it a day. I give up. Oh yeah. I give up. Because it's like... I'll show you the 150 before we go. This is the 150. This beast of a soldering iron is the 150 watt. This thing will go through everything. It's in fact how I remove the chokes. It's how I remove the DVI connector, mostly. It's how I remove... like, this thing is really, really good at removing everything. The problem is, it puts out 150 watts. So if you're working on something, right, that something very quickly gets so hot that you basically can't handle it. Like, you can't move it around, you can't touch it. You're basically constantly, it's like, oh yeah, I'm working on this PCB here, let me just... And it throws off so much heat that just having your face near it makes you feel really, really hot, which in the middle, like, with the start of summer, it's like, yeah, I really want to be working with this thing. Yeah. And then, you know, it's also heavy, which, like, that's not a huge problem, but just working with it is, like, you can't hold it with 2 fingers. Like, you can't really hold it like that, because it's heavy as hell. And, yeah, but the reason why I have this, I'll show you why. Is because... So, the reason why I have that is because sometimes you're working on a card like this. Is because, you know, you're working on something like this, and here, this is really good. So this works great because you're working on giant blobs of solder in like, oh, there's a ground, that, and this puts down so much heat that it'll actually keep that entire puddle of solder over there liquid. So it's awesome, you know, you can just solder pretty much anything to anything with this. Because, you know, it's like, oh yeah, I'd like to do my power board because this is a GTX 570. It's like, yeah, I'm going to do it with 8-gauge wire. So you basically just take your 8-gauge wire and just go like, yeah, bam. Of course, you're not going to be holding the 8-gauge wire because if you were holding that, you can see the insulation's not doing great. My fingers would be doing worse. Yeah, this thing is great when you need to solder onto power planes because it doesn't matter that the power plane is a heatsink when this is a giant flame-spitting monstrosity. The problem is it's unregulated. There's no temperature regulation in it. As far as I can tell, it seems to when I'm working with this, I very strongly suspect that it exceeds 450 degrees on UK power, because this is rated for 230. UK power is 240, and this thing, like, if I set 450 degrees on the little iron, it's not even a case of like melting through this. It's just, I've seen this set start like this glow red hot, like not the actual metal itself, but when I apply fresh solder to it, the flux core from the solder seems to burn up instead of just like vaporize. It just straight up burns. So this thing is a kind of concerning to work with. And also it's just like, where do you put it on your desk, right? You put it somewhere and that entire area becomes a hot spot. So I hate working with this thing, but it's a necessity because you can't do anything otherwise on power boards, because you try to Like, I couldn't get this to melt with the little one at all. Like, I couldn't put a dent in that. So, yeah. And incidentally, if you're like, Buildzo, you must be using the wrong tool for this. I asked Der Bauer, who does way more power boards than me, like, he did something like 20 plus power boards at this point. He bought the entire supply of e-powers for Europe once. So, he does a lot more power boards than me. And I was like, yo, I need a soldering iron because mine isn't good enough for power boards. And he's like, buy this. Well, I bought this. This thing is insane. And, you know, it does power boards great. It's just not very fun to work with. So, yeah. That's what I use. Yeah, about the lead-free and leaded. I had, back in the Czech Republic, I was using lead-free solder. I was running onto leaded. Yeah, I had leaded. Back in the Czech Republic, I was on leaded solder. I had all the same problems I have here with lead-free. It's just a case of I can't push enough heat into the PCB fast enough to get the solder on the PCB to melt into the solder I have on whatever else. It's just, yeah. I don't know. It just seems like with the... Because the one thing I've always noticed is, like, if I take the little iron and try to do something with it, right, solder something, and then the moment I take the iron away, you can put your finger right on the spot you had the iron on, and it's cold. It's ice cold. It's, like, it basically feels like you've never had it there. So, yeah. I'm not sure. It's just... It definitely is like, it's something I could improve on, but it's just like, I have no idea how. It's just... Soldering power planes just sucks in general, as far as I can tell. Yeah, see... Preheat the board, use a hot air station. I'd need a hot air station to do that with. I literally just have a soldering iron. So, that's all. And it's like, yeah, it's like I need more equipment. Definitely need more equipment to do these kinds of things, but it's just equipment costs money. And AHOC is just like a complete cash sink, as is already. So, you know. And I'm kind of... Personally, I'm okay with, you know, my soldering not being incredible, but at least, like, I can get around enough that, like, it works enough that it works. You know, it's like, it works. It's not pretty. It's probably not very good, but it works. So I'm kind of okay with it. Whereas, sort of going into the future, so basically, going into the future equipment-wise, I'm thinking of getting a good oscilloscope before I start investing into better soldering equipment. Just because I want a good oscilloscope, because oscilloscopes are awesome. It's just like... So, yeah. How about a good multimeter? This thing is good enough. Okay? It's trash, but it's good enough. I can work with this, right? I can work with this. That oscilloscope, the little red one I have, I can't work with that. That is useless. That is borderline useless. It's good enough to see, like, yeah, it's not a steady voltage, it's an actual signal, or it's like, oh, you know, it's useless for anything past that. This, I can read a voltage, I can measure a resistance. It's not great, you know, I have to wait a month for it. It has a current clamp, which really this is the part I most wanted about this. That was like I needed to be able to read like how much power I was pulling through things. So I got it for the current clamp part. But then again, the current clamp part also sucks because oh look, we're reading 50. We're reading an amp. We're reading almost 0, which is quite frankly that's just inherent to the design of this thing. It's a Hall effect sensor, but still, yeah. I mean, it works, you know. Plus minus an amp isn't really the worst amount of error to have when you're working on things that are about an amp, 10 amps of power draw at least. Have I done a Ryzen OC stream yet? Nope. I had the Tai Chi BIOS is fixed. There's a video on the channel about how ASRock have fixed the BIOS, which is super nice. Somebody asked if I watch EEV blog. Yes, I do. Actually, let's see. Can I get this pointed upwards enough that you can see me? Oh, no, just sliding off. Wait. There we go. Ta-da. Somebody asked if I'm streaming tomorrow. I will be. Yes. I do plan to stream tomorrow. This is awkward. There. So, yeah, I think let's pack it in here, eh? The board works, which is what I wanted to get through. How long was this? Oh, almost 3 hours. So that wasn't that bad. And I am streaming tomorrow. I will be doing the GTX 1070 for the ROG OC Showdown competition. I'm not sure how that'll go. I'm really worried. I've already, like, the boost algorithm on NVIDIA cards, quite frankly, it's just, I hate it. I almost recorded a video earlier today where I was just like, do you know, the boost algorithm is, like, basically did a Tai Chi level, like, a similar rant to what I did for the Tai Chi, except about NVIDIA's boost algorithm, because... yeah, it's just annoying. And yeah, the 1070 is on Ryzen. It's on the Asus B350 Plus board. The problem is that motherboard doesn't go over 1.4 volts. At all. And the voltage controller is an ASP1106, which is a Asus rebranded part. And my usual contact for Asus seems to be at Computex and very busy. So I'm not sure... like, oh no, I know how Boost 3.0 works, it's just, I find it incredibly infuriating. It's just annoying. But yeah, no, it's, the Prime is, like, I can run 4 gigahertz for Time Spy, it's just not good. It's really not good. Cause, yeah, I'd like to be able to run a higher clock, and I'm not sure how well LN2 will work on the B350 Plus. Like, there's some concerns I have, and it's just like, I don't know, I'm really unsure about it. And I'm not really sure how to approach the stream because of that. Do I throw it under LN2 right off the bat? Do I, yeah, that's the thing, it's just, I've even considered, like, you know what, maybe I could just hook up the power board. A power board to the card, to the motherboard, like, just grab the E-Power, replace the V-Core VRM, and then be done with it, because the E-Power can go up to whatever voltage I'll ever need. Speaking of the E-Power, I still need to mod the voltage control on that upwards a little bit. Yeah, I'm not sure, like, I know that just putting LN2 on the CPU with 1.4 volts will make it clock better. I'm just not sure how much better, and I'd really like to be able to hit 5 gigahertz. So, yeah. How much did it score in Time Spy, somebody asked. The best score I've gotten out of Time Spy is 6,700 overall, and this card this card isn't stable above 2 gigahertz. Like, it's barely stable above 2 gigahertz. It's really, really bad. And I've tried adding extra capacitors. That didn't help with voltage. That didn't help with stability. I do want to volt mod the card. That is definitely on the menu for tomorrow. But I guess we'll do a air-cooled stream of the 1060. I guess. I'm not sure. I just... Yeah, I have too much on my plate right now, and... Yeah. I am not modding the... There's no way I'm modding the Prime tomorrow. Or today. I'm done. I don't have an LN2 score for the 1070. The best 1070 ever on liquid nitrogen is 2.34 gigahertz. And that for Time Spy that was like just over 7,500 points graphics. If a MOSFET blew up on a VRM, you might have a chance replacing the VRM with a power board and it'll work. Like, it's really hard to say. Sometimes the GPU core doesn't survive, sometimes it does. So it's worth trying, generally speaking. I mean, you can, you know, you just pull all the chokes. And once you pull all the chokes, solder in the power board, you don't even need to use all the wires if you just want to see if it boots. And if it boots, then you can go and add more wires. So, yeah. Yeah, I've gotten, my card, I've gotten it up to, so I got 6.7K overall, and just the GPU alone, I think I got it to like 6.4 graphics score? I am not sure right now. This card doesn't score well. But yeah, and that was after like power mods for the card because it power throttles so hard. Even after the shunt mod, it power throttles so hard. But I have an idea to completely disable the power limit, which I can't. Like, I've already sent an email about that, and I am waiting for a response. If I don't get a response on time, then that GTX 1070 is losing its power limit the experimental way tomorrow. So, yeah. That's about it. At least, unlike the GT 730, the 1070 is scoring where it should be. Which is a good thing. The score isn't trash for no apparent reason. So, yeah. I'm not sure. We'll see how that goes tomorrow. And let's end this here, I say. We get this. Come here.
Mankind as we knew it is doomed.
Where did the mouse go? Oh, there it goes. Found it. And... yeah. That's it for today. Thank you for watching, and see you next time.